Hi everyone, this new propeller launcher is engineered to send propellers flying as far as humanly possible.
Oh my god.
This new launcher is fully 3D printed and relies on the input power from the user's arms to propel the propeller extremely far. It works by accelerating the propeller to an absurdly high speed, and once the user stops accelerating the prop flies off.
Oh my god.
The gearbox has a 184 to 1 ratio, so the props can accelerate really fast before flying off in the distance. So let's look at the design. The most important component of the design is the gearbox. It starts with a long lever arm crank handle, which provides maximum input torque, as well as a bearing mounted pommel for smooth operation. Stage 1 of the gearbox is a planetary gearbox, followed by another planetary gearbox, which is followed by a set of spur gears to provide easy gear ratio adjustments, as well as bevel gears to reorient the axis of rotation. Here we can see the exploded view of Stage 1. The Stage 1 planetary gearbox carrier is supported by two ball bearings to ensure the axis of rotation is well constrained under high torque. Removing the cover shows that each of the planet is supported by a shaft that is mounted again on two bearings to also support those shafts and planets really well at higher torque and higher input loads. You can see the six planets which distribute evenly the input loads for maximum strength. Stage 2, another planetary gear set, this time only has three planets for higher efficiency. It doesn't see as much input torque or load, so having six planets wasn't necessary and we can have a higher gear ratio. The carrier connects to stage 1 as such, and we can now look at how smoothly those gears spin. This is printed in place, by the way, because you couldn't assemble those herringbone gears together otherwise. Stage 3 of the gearbox and 4 actually come together, and this is a set of spur gears, again herringbone gears. These doesn't have to be really strong because the torque at this point is divided by quite a lot, about 14 actually, and the ball gear connects with this pinion gear on the output shaft, which is supported by two bearings and mainly serves the purpose of clearing the end of the user. That's why it's so long. It's to make sure that the prop doesn't fly and hit your hand as you're cranking this thing, and you can see how smoothly it spins. Finally, a grip and stock are both necessary to ensure that the user can brace the launcher against their body while applying high torque to the gearbox. So now, let's see it in action. Here is a first-person view of a launch. We just mount the propeller onto the shaft and give it a spin. The launcher does really well, but there's just one problem. The propeller on the hinges itself too fast. Actually, it vibrates itself off of the connector because it's spinning too fast. This is because of imbalance issues, and this leads to a reduction in performance because it cannot fly as fast as it could, nor store as much energy as it could. So, to solve this, I reduced all the clearances at the output shaft and propeller interface, and this really helped make it perform a lot better. As you can see, it sounds a bit different because it goes much faster in this test. And walking all the way up to the propeller, you can see that it flew all the way across the park. So yeah, in the future, I'm definitely gonna have to go and test this elsewhere. So using Google Map to do a scaling calculation, I found that this flew 110 meters or more than 350 feet. And this is three times more than my previous design.
It's just how far it goes.
I then went elsewhere for more testing, and actually this propeller flew off way above the power lines. You can see it going in the field in the back. So this new design is great, but I think there's still some room for improvement. For example, with this very big
Oh
propeller,
my
you can
god.
see that I'm having a really hard time spinning the crank handle fast enough. I think there's probably more power I can input into the gearbox with maybe a lower gear ratio. So the next video is going to be about optimizing the performance of this launcher by tuning the gear ratio. Then I'm thinking about maybe doing a weed eater with it or a leaf blower. I have many ideas. Let me know if you have more ideas about it, more improvements I could do. I'm really listening for those, and I might also do a video about those. Thanks for watching. If you like this video, please like, share, and subscribe. This is really going to help me make more videos like this.